Fluid compressibility is the ability of a fluid to change its density when a pressure is applied to it. As seen in the diagram, fluid in the vessel initially has a lower pressure, which means it has a larger volume and lower density. When there is an increase in pressure of the vessel, it has a smaller volume and a higher density. The compressibility factor Z is a unitless variable that calculates the amount the thermodynamic properties of real gases deviates from ideal gases. It is used for cases where fluids follow the behavior of real gases and do not follow the ideal gas law. Z is given by the pressure times the volume divided by the number of moles, specific gas constant, and absolute pressure of that particular substance.
A compressibility chart is a tool used to determine the properties of gases or gas mixtures with acceptable accuracy for most engineering purposes. Compressibility charts are used to perform accurate thermodynamic calculations. A compressibility factor tells us how much the real gas deviates from the ideal gas at a given temperature and pressure. It is used as a correction factor to ideal behavior in most engineering work. The ideal gas theory fails at predicting the thermodynamic states of real gases in a dense phase. Hence, in this aspect, the compressibility factor is then introduced to measure the deviation of a real gas from the ideal gas. In general, deviation from ideal behavior becomes more significant the closer a gas is to a phase change. Ideal gas behavior is indicated when this ratio is equal to 1. Any deviation from 1 is an indication of non-ideal gas behavior. Reduced temperature values can be obtained by using the equation Tr is equals to actual temperature over critical temperature. Critical temperature is fixed for a gas in question and is then varied against actual temperature, which allows a curve to be drawn using the values of the ratios. The higher the actual temperature of a gas, the closer the reduced temperature line is to an ideal gas. When the compressibility factor tends towards 1, reduced pressure also tends to 1 or is either high.
Now let's look at an example comparing real and ideal gases when calculating thermodynamic properties. We are given 3.5 kilograms of propane in a rigid tank at 4000 kPa. It is initially at 110 degrees Celsius and is heated to 130 degrees Celsius. We work out the reduced temperature and pressure using thermodynamic tables, and we get Tr to be equal to 1.035 and Pr to be equal to 0.937. We then find the point of intersection of these two values on the compressibility chart. The y-axis point of intersection of these two quantities gives the compressibility factor Z. Using Z, we can calculate the initial volume in the tank to be 0.034 meters cubed, whereas using the ideal gas law, we calculate the initial volume to be 0.063 meters cubed. This gives a percentage error of 46%, which hence shows the case when compressibility of fluids deviates from the ideal gas law. Therefore, the compressibility chart needs to be used to calculate the fluid's thermodynamic properties instead of using the ideal gas law. Thank you for watching this video on the compressibility of fluids.